keep a close eye on 3I Atlas, a Manhattan-sized interstellar object believed to be a comet getting closer and closer to Earth.
A mysterious visitor from beyond our solar system is defying every rule astronomers thought they knew about comets, and its bizarre behavior is forcing scientists to question everything.
A huge update on our favorite interstellar object. It could be the biggest update in the solar system. Take a look at this. This is 3I Atlas.
Today, we reveal why 3I Atlas is way scarier than you think. Unprecedented speed through space. 3I Atlas is tearing through our solar system at a mind-blowing speed of 336,000 kilometers per hour, making it the fastest interstellar object ever recorded. This velocity is roughly 58 kilometers per second relative to the Sun, far exceeding the speeds of the two previous interstellar visitors, one Oumuamua at 26 kilometers per second and two Borisov at 32 kilometers per second. The object's incredible velocity reveals that it has been drifting through interstellar space for billions of years, with gravitational encounters from countless stars and nebulae adding momentum and ratcheting up its speed. Scientists at NASA confirmed that this breathtaking sprint is evidence of an unimaginably long journey, and its trajectory is so extreme that it follows a hyperbolic path with an orbital eccentricity of 6.137, the highest of any known interstellar object. This means its path through our solar system appears almost straight rather than curved, and it will never return once it exits between late November 2025 and January 2026. Water emission far beyond normal range. 3I Atlas is doing something that should be impossible, releasing massive amounts of water vapor at a distance where comets normally remain frozen and inactive. Using the ultraviolet optical telescope on the Neil Gehrels Swift Observatory, astronomers detected the object expelling approximately 40 kilograms of water every single second at a distance of 2.9 astronomical units from the Sun. This places 3I Atlas nearly 3 times farther from the Sun than Earth, where sunlight is typically not strong enough to turn surface ice directly into gas through sublimation. The production rate is comparable to a fire hose operating at full blast, and scientists believe the nucleus is ejecting a spray of tiny ice-coated dust grains rather than sublimating ice from its surface. These smaller particles have a much larger surface area compared to their volume, allowing faint sunlight to heat them efficiently and create the vast cloud of water vapor observed around the comet. Researchers at Auburn University stated that this places 3I Atlas among only a handful of comets with confirmed hydroxyl emission beyond 2.5 astronomical units, requiring that over 8% of its surface is active, which is larger than activity levels observed in most solar system comets. Mysterious nickel emissions without iron. Observations from the Very Large Telescope in Chile detected something truly puzzling about 3I Atlas: the presence of atomic nickel vapor without the expected accompanying iron. Between July and August 2025, astronomers identified 22 emission lines corresponding to nickel transitions in spectra of the comet, with the strongest lines appearing on July 20th. By August 21st, the object was emitting 4.6 grams of nickel per second, along with 17.6 grams of cyanide per second. The mystery deepens because nickel and iron are typically found in roughly equal amounts when outgassing from comets, yet no iron vapor was detected in 3I Atlas. While nickel emission has been seen in other comets, including the previous interstellar visitor 2I Borisov, the absence of iron is highly unusual. Scientists have proposed that the nickel vapor might be released through chemical decomposition of nickel-containing organic compounds, such as nickel tetracarbonyl via space weathering. but the exact mechanism remains uncertain.
Before we go on, like this video, smash the subscribe button, and click the notification bell right now.
Tail reversal phenomenon. 3I Atlas exhibited a rare anti-tail feature that pointed directly toward the sun rather than away from it, and then mysteriously reversed direction as it approached closer. The European Space Agency confirmed this anti-tail phenomenon, where sunlight reflects backward, creating a visual effect opposite to typical comet tails. Early observations in July 2025 showed a sun-facing dust fan, but by September, the morphology had changed dramatically to one dominated by an anti-solar dust tail at later dates. Independent spectroscopic observations indicate that carbon dioxide is the primary driver of activity on the object, and researchers attribute the delayed emergence of the normal tail to the large size of dust particles with an effective radius of 100 micrometers and their slow ejection velocity of 5 meters per second. Scientists explained that as 3I Atlas approaches the Sun, the exponential temperature dependence of the sublimation rate causes a continuous increase in the production rate of ice fragments, and a sharp decline in their residence time in the outflow. The combined effects produce a peak in total scattering cross-section due to water ice grains at a distance of 3 to 4 astronomical units from the Sun. Unexpected brightness surge. In early August 2025, 3I Atlas shocked astronomers by becoming dramatically brighter than predicted calculations suggested. Based on the object's decreasing distance from the Sun, scientists expected its magnitude to increase to 20.5, as the amount of energy it received would increase by a factor of 1.5. Instead, the object got much brighter than that, with its magnitude jumping to 19.28. This shocking surge in brightness was the result of 3I Atlas increasing its flux by a factor of 5, not 1.5. Observations with the TRAPPIST North and South telescopes reported similar brightness values, confirming there was no miscalculation. With such a huge amount of energy radiating from this object, 3I Atlas is far more active than originally thought, and may have been active for a long time. By October 2025, forecasts suggested the comet could reach a magnitude of 12 around late October, as it approached perihelion on October 29th. Size and structure uncertainties. The exact size of 3I Atlas remains a subject of debate due to the reflective dust coma surrounding its nucleus. High-resolution images from the Hubble Space Telescope in July 2025 indicate that the diameter of the nucleus is between 0.32 and 5.6 kilometers. The large uncertainty exists because the coma makes the nucleus appear brighter and larger than it actually is, with early estimates reaching as high as 10 to 20 kilometers before being revised downward. Hubble images show that the coma's brightness accounts for a large fraction of the nucleus's apparent brightness, suggesting the actual diameter should be at the lower end of the estimated range. The estimated dust loss rate indicates the nucleus is likely less than a kilometer in diameter, similar to 2I Borisov. The coma itself spans approximately 26,400 by 24,700 kilometers in diameter, according to observations from the Gran Telescopio Canarias, about twice the diameter of Earth. Additional observations from the SPHEREX mission showed a more extensive carbon dioxide gas coma spanning at least 348,000 kilometers in radius, though it is only visible in near-infrared. Training ground for planetary defense. The International Asteroid Warning Network launched a coordinated observing campaign using 3I Atlas as a training exercise to improve detection and tracking capabilities for future potentially hazardous objects. While the comet poses absolutely no threat to Earth and will remain far away at its closest approach of 1.8 astronomical units, or approximately 270 million kilometers. Its relative proximity is good enough for observations by small telescopes. The project serves to not only predict the orbit of 3I Atlas, but to perform astrometric measurements tracking the comet's speed and motion in Earth's sky, relative to objects like stars. This information will be used to inform future observations of comets, or asteroids, that may be a threat to Earth. The network notes that comets are especially hard to observe because their tails and atmospheres make it difficult to estimate overall brightness, which in turn affects pathway predictions. Objects entering from beyond the solar system travel faster and follow unpredictable paths, giving scientists less time to gather precise data. The collaborative efforts help refine the ability to detect, verify, and track potentially hazardous bodies in the future through improved orbital modeling techniques and global coordination systems. Discovery and confirmation. The Asteroid Terrestrial Impact Last Alert System survey telescope in Rio Hurtado, Chile, first reported observations of 3I Atlas to the Minor Planet Center on July 1, 2025. Since the first report, observations made before the discovery were gathered from archives of 3 different Atlas telescopes around the world and the Zwicky Transient Facility at the Palomar Observatory in San Diego County, United States. These pre-discovery observations extend back to June 14, 2025. Astronomers categorize this object as interstellar because of the hyperbolic shape of its orbital path, meaning it does not follow a closed orbital path about the Sun. When the orbit of 3I Atlas is traced into the past, the comet clearly originates from outside our solar system. It marks only the 3rd confirmed interstellar object ever observed passing through our cosmic neighborhood, following the discoveries of 1I Oumuamua in 2017 and 2I Borisov in 2019. The object reached its closest point to the Sun on October 30, 2025, at a distance of about 1.4 astronomical units, or 210 million kilometers, just inside the orbit of Mars. Let us know what you think in the comments below, and don't forget to subscribe so you don't miss any new videos. Thanks for watching.